As you can see, there is a table of arithmetic instructions in MIPS assembly. So there are each instruction's meanings, its comments, etc. And the syntax in MIPS, how do you have to write these instructions. So let's take a look. Before to start, I'd like to explain you some really important things. So, in order to represent number, the number can be either unsigned or signed. What does that mean? So the number, if the number is inside of the unsigned instruction, for example, let's say we have instruction addition, add, right? It can be either signed addition or unsigned addition. What does that mean? So it means that if the number can be only positive or unsigned format. Um, let's write here positive. Signed format either positive or negative. And how do we work with them? So if we have unsigned number, the thing is each register in MIPS has 32-bit format. But if we have number in the code part, let's say if the number is 16 bits or 8 bit or 24 bits, doesn't matter. If it's less than 32 bits, we have to extend number up to 32 bits. For example, let's say we have $1 register and its value is, let's say, 7A81. So the thing is the number is 16-bit value. But we have to extend it to the 32-bit format. So how do we do it? First of all, we have to represent this number in a binary format. And we have to take a look on the first bit. If the first bit is 0, so the number is positive. If the first bit is 1, so the number is negative. That's kind of, reminder for you. So the first bit is 0, but right now we are working with the unsigned representation. So we don't care if the first bit is 0 or 1, the number is going to be always positive. So it's 16-bit, right? So we have to extend to this 32-bit. So what do? We just add zeros. 0, 1, 1, 1, and so on until 0, 0, 0, 1. So the updated value is going to be 0x0000 7A81. That's for the unsigned. But for example, let's say if we had not 7, maybe we had 8, and the first bit is 1, we don't care if the first bit is 1 or 0. Zeros are going to be added to the 16-bit value. Why? Because the number is unsigned, the instruction is unsigned instruction. All right. But what if we have signed addition, let's say? So $2 is going to be 0x F1. Okay. That's 8-bit value. And we want to extend to the 32-bit. So what do we do for that? We have to display its binary representation. So the first bit is 1, so the number is negative. If it's signed instruction, we care about the first bit, and the extension is gonna be 1, 1, 1, 1, 1, 1, 1, 1. So that was our initial format, and we added how many? 24 ones. So total is gonna be 32-bit. In other words, 0x f f f f f f f 1. All right. I think you understood this. Okay, let's go to the other ones. Actually, we didn't even start yet. Okay, add instruction. So what do we do? Here we have three registers. Let me remind you that in the activity one, let me compare. We have only two registers. What do we do with them? We just add them together and store the value into the destination register. This one is dest. This one is source. So what about here? We add register $2, register $3, and store the value into the $1. What about subtract is the same thing. What about add immediate? By the way, all of them are signed here. All right. So the only difference is that we have constant number, integer. We have only integer part here. So we add them together and store the value into the $1. This one is unsigned, but let me write here, but it's obvious. The same thing here. Add immediate unsigned, same thing here. Okay, multiply without overflow. It means that, if we multiply two 32-bit numbers and the resulted number is going to be more than 32 bits, we exclude those 33, 34, 35 bits, and we remain only 32 bits. Let's say in other simple English words, uh, out of the range bits are eliminated. We don't use them. Only 32 bits. In other words, low part of the. Okay, let me come to the second register and I'll explain you what do I mean by low. So here we have only two registers. We multiply them together and we store the value. Actually, the value is not existing. It's split into the two registers, high and low. The upper 32-bit, let's say we have the 64-bit number. Why? Because when we multiply 32-bit by 32-bit, the number is going to be 2 to the power 64, 64-bit. So the 64-bit value is split by high part and a low part. So in the multiply, in the mult instruction, the value is going to be split into two registers, as I said. Here are going to be some numbers, here are also some numbers, okay? What about divide? The same thing, we split our value into the. Actually, it's not the same thing. The similarity is only the um, registers high and low, but the meaning of them is totally different. In the high register, we store only the remainder part. In the low, we store only quotient. What is quotient? Quotient is the integer part before the comma. What do I mean? Let's say 5 divided by 2 is going to be 2, and 5 modulus 2 is going to be 1. So this one is quotient, this one is the remainder. So if we do this operation, 5 over 2, so the 2 is going to be 2, and then dollar sign high is going to be 1. So that's how it works. Thank you for attention.